Okay, so here we go, section 7.1, ratio and proportions. This is a big section for the entire chapter because we'll be doing proportion all chapter long and setting up ratios and simplifying them. So most of this should be review. If it's not, that means you definitely need to come in and talk to me. Yeah, hopefully this is a kind of a nice, easy, just ease into chapter 7 and ease into this process. Okay, so we've solved problems by solving and writing equations. Now we're going to write ratios. Now we're going to write and solve proportions. So the first thing you're supposed to do in your notes is to define ratio, and the only thing I really need you to get for that is right here, a ratio. Whoops, undo that. Let's do highlighter. A ratio is a comparison between two quantities using division. And be aware there are three ways to write ratios: A to B, A colon B, or A over B. Most of the time this year we'll do it as A over B. But we could do it, the book could do it any way it feels like doing. And here's their example of just a simple ratio. Hey, we have two TVs here, which is really what this is. And 32 by 20 or by 18 is the same thing as 16 by 9 because when you put them into division, they both reduce to 16 over 9. All right, so here's what's going to happen now. The first problem is going to pop up. It's on your notes. I'm going to, in a second, a little question is going to pop up for you to do this problem. Click the answer you think is best, and then go on. If it's wrong, you can watch me do it. If it's right, you can skip ahead. So in Logan's High School, there are 190 teachers and 2,650 students. What is the approximate student-to-teacher ratio at his school? Okay, now the thing is this: I'm going to do both exact and approximate. So on the answers, you'll see the exact ratio, and then I'll show you what they mean by approximate. Okay, so good luck. Okay, so here we are back at this problem. In Logan School, there are 190 teachers and 2,650 students. What is the approximate student-teacher ratio at his school? Now, the key to this is the order, and a lot of people wouldn't realize this when they do it, but it does say student first, teacher second. So what that means for us is it needs to be student to teacher when we do the problem, so we need to put students over teacher. I'm going to do S for students, T for teacher. So there are 2,650 students and 190 teachers. Now the exact ratio for this, those just both simply cancel out to be 265 over 19. And 265 and 19 don't reduce any further. This is exact. 19 is prime, that's why I know it doesn't do that any further. Now, that's what the problem said, what's the approximate ratio? So that's where we get our calculator out, and we can divide 265 by 19. Okay. So we're going to divide 265 by 19. And what that gives us is 13.94, so it's approximately 14 to 1. Which means really you have 14 students for every one teacher. Okay. Now, along with simple ratios like this, we also have something called extended ratios. And an extended ratio is when you compare more than two things at a time. So for the definition, you can just say definition is can be used to compare three or more quantities. And then the way we'll write them out a lot of times is A to B to C. Now, it could be more than that. It could be A to B to C to D to whatever. Yeah, that's our definition. So it can be used to compare three or more quantities. And again, if you ever need to, because I'm going too fast, just pause the video, write it down, and then push play again. And the way it works is that all three are related to each other. So A to B, B to C, and A to C. Now, here's an example. I'm not going to make you work this one out. I just want to walk you through it real quick. But we have an extended ratio of 30 to 60 to 90, basically. So we have a triangle. 30, 60, and 90 are the three angles. The question is, what's the simplified extended ratio? Well, the initial ratio would be 30 to 60 to 90. And so with that, then, it's a matter of just simplifying the ratio itself. Hopefully you catch on pretty quickly. Hey, all these divide by 30, or divide by 10 first and then 3, whatever. Either way, it doesn't matter. Once you divide them all 3 by 30, you get 1 to 2 to 3. So there's the extended ratio simplified. There's the original extended ratio. All right. Now, the next thing that should be familiar to you from previous class is proportions. So this is going to be big for us for the rest of the semester, and specifically for this chapter, where we have to set up two ratios and solve, and that's a proportion. So definition-wise, a proportion is an equation stating that two ratios are equal. That's the definition. What you may remember from previous classes is doing fraction over fraction like this. A over B equals C over D. Now the numbers A and D, they're called the extremes. B and C, they're called the means. We will come back and talk about that next chapter, why we call one the extreme and one the means. Okay. But what you probably remember also from proportions is whenever you have the extremes and the means, you multiply those together. A times D, B times C, those are what's called cross products. Okay, so that's basically what we use to solve proportions. Okay, take the cross product. Right. So here's the next part for you. Again, if you need to pause it to copy this in, that's fine. Otherwise, just listen to me jabber on. So in a proportion, the product of the extremes equals the product of the means. That's what the cross product property says. Symbolically, if A over B equals C over D, then we know this. A times D equals B times C. Okay, those two guys are equal. And B and D can't be 0 because of the fact you'd be dividing by 0. And here's a little example of this. 4 over 10 equals 6 over 15. Both those reduce to 2 over 5, actually. But if you cross multiply them, 4 times 15 is 60. 6 times 10 is also 60. Those two guys are equal. And that's actually how you prove that two ratios are equals. You do the cross product and see they get the same thing. Okay. Another point the book brings up, which I'd be remiss if I skipped, is equivalent ratios. Okay, so equivalent proportions, equivalent ratios, same thing. It doesn't matter sometimes how you write these out, and that's going to be something when we get to word problems later in the chapter that's going to throw some of you off. You'll write it differently than somebody else did, and you'll be like, why did I get this answer, and why did I get this answer, and either they're the same answer or different answers, and you can't sort it out. And what it comes down to most times is you had the wrong cross product to begin, or wrong proportion to begin with. But the key to this is all four of these say the same thing, because all four of them in the end end up being A times D and then B times C. So if we look at this real quick, notice, this was A over B equals C over D. This is that first original proportion the book defined. Then what did they do? Well, they flipped both A and B and C and D. Okay, I still get the same cross product. So as long as I flip the two fractions, we're okay. If I look from the first to the third, what did they do? Oh, they swapped B and C. B was in the bottom left, C was in the upper right. Now B is in the upper right, C is in the bottom left. It doesn't matter, I still get B times C. And then what they did is they took the second one here and they swapped B and C again. So they flipped it. So there are multiple ways to write these proportions, and again, when it comes to the word problems later in the chapter, some of you are going to be really upset at times because someone's going to write it differently, but you're going to get the same answer. Okay. All right, so here's the next one, and this is one you don't have to write out, but I did want you to try it real quick here. So of these four down here, of these four, only one of them does not match this statement. So I have P over Q equals R over S. The question is, which one of these four does not have an equivalent relationship? And this PRSQ means P times R, S times Q. And this PSRQ means P times S, R times Q. So I'm going to click the blue box in a second, and it's going to pop up and ask you to answer A, B, C, or D to which one you think is not true. If you need to, pause it right now, give yourself a minute to work it out, and then click it, because once it pops up, it's hard to see the problem. So here we go. Okay, so back to the problem now. The key to this is I have to look at the original cross product, which in this case is PSRQ. That's the first one. So I want to see which one gives me P times S, R times Q, because that's the original cross product. P times S, R times Q. Okay. Now, this one does. This is R times Q and P times S, so A is okay. B gives me P times S, and Q times R, so that one's okay. But if I look at C right there, it says P times R, S times Q. There's my answer right here. C is the one that was not true. And if I look at D, it is PS times RQ, so we can double check that. Okay, great. Now, the last couple examples here are just some review of algebra. So what I'm going to let you do on this one is I'm going to allow you to skip it if you get the right answer. So I'll have you to solve this using proportions, cross multiply. If you don't remember how to do that, just say, I have forgot how to do it. Watch me do the problem real quick, copy the work down, and then go on with it. So here we go, nice and easy. So it's going to ask you then what's the answer here in a second when I click the button, and then fill in the answer. Alright, so here's our problem. I've got x over 4 equals 11 over negative 6. How we solve proportions, this is something you might remember doing in Algebra 1 or before, is you're going to use the cross product. So what you do is a lot of times people like to circle these guys. Say, oh yeah, this times this equals this times this. That's fine. And I don't care if you circle or not. Then you'd write x times negative 6 equals 4 times 11. Some of you like to skip this step and say negative 6x equals 44. Fine with that as well. Okay. Then we're going to divide by negative 6 to solve. Reduce it because it can divide both by 2, and that gives us 22 over negative 3, which is equivalent to negative 22 over 3. And that's the answer you should have clicked. Okay. All right, now the next problem. So this one's got a little bit more work to it. 7 over z minus 1 equals 9 over z plus 4. So I'm guessing if you forgot how to do any of these proportion solving wise, it might be this one they make a mistake on. So, pause it, do your work, and then answer the question. Alright, so we've got 7 over z minus 1 equals 9 over z plus 4. So I'm just going to, again, cross multiply to solve the problem. Okay, it's going to give me 7 times the quantity z plus 4, and this is where most people make their mistakes, is they forget that should be in parentheses. 7 times z plus 4 equals 9 times z minus 1. Okay. And now what I'll do then is I will distribute the 7 to both of them and the 9 to both of them. So I get 7z plus 28 equals 9z minus 9. And then up to this point here, it's your solving of algebra. I prefer to keep my z's positive, so I'll subtract 7z. And then I will add 9 to the opposite side. If you want to do it in 2 steps, I'm okay with that. I just do it in 1 because I'm lazy. So now I get 37 equals 2z. And then divide both sides by 2. And that's our answer, we're going to say. 37 over 2. We'll just leave it as a fraction. Okay, so hopefully that was pretty painless. I know I was moving pretty fast some parts. I was trying to get you in and out in under 20 minutes at the most. Hopefully it was. And then, we'll go over the more advanced problems tomorrow in class. Again, if you have any questions at all, come in tomorrow morning before school. I'll walk through any of these problems with you again or anything you didn't quite get. All right, great, thanks.